Welcome back. In this video, we're going to look at type 2 quadratic problems. It's about projectiles. So in these kind of questions, you are typically given an equation that represents whatever's happening. And in this case, you have a ball that's being thrown from outfield, and it's given by the equation h equals 2 plus 30t minus 5t squared, where t is the time in seconds. So this would be a upside down parabola, for instance, something like that. And it's asking to calculate the maximum height that's reached by the ball. So if you look at this question right here, the maximum height is right there at the vertex, and it is going to be the y value of the vertex because it's on my vertical, right? Okay, so in order to find that, we need to figure out what the x value of the vertex is first, and then use that to figure out what the y value of the vertex is, which is going to be the height, because our equation says height equals. Now let's take the equation that we have and rewrite it so that we've got our x squared term, in this case our t squared term first. So that's what it looks like. Then we figure out what the x value of the vertex is going to be. And in this case here, really what we're solving for is t. So that's the time at which it reaches its maximum height. And same process as we've done before. So we've got minus 30 over 2 times negative 5. And that gives us, at time of 3 seconds, that's when it reaches the maximum height. But the question in part A actually asks us the maximum height that's reached. So we want to figure out what the height at 3 seconds is. So we take our equation from above here and just plug in t equals 3. So plugging in t equals 3 gives us 2 plus 30 times 3 minus 5 times 3 squared. And we end up with 2 plus 90 minus 45 equals 47 meters. So we can say that the maximum height is 47 meters, right there. And if we look at the next question in part B, we've already answered it. We just have to state the answer now. It's asking how long does it take to achieve this maximum height? So that's the time it takes to go from here to here. And we found that that was 3 seconds. So all we need to say is it takes 3 seconds to reach the maximum height. Okay, let's move on to the next one. This question is very similar to the one before, so I'm going to encourage you to hit pause and to try this question on your own. The only difference is the numbers, really. Now that you're back to see what the answer is, here it is. All right, so when we find the x value of our vertex, we have x equals minus b over 2a. And really, this is the same as finding t, right? Because we have our equation in terms of t right here. So our time that our ball, in this case, reaches its maximum height is 3 seconds. So we need to figure out what the actual height is. So we take our 3 first time and we plug it back into our equation right there and end up with h of 3. That means the height at 3 seconds equals minus 4.9 times 3 squared plus 29.4 times 3. So h of 3, our height is 44.1 meters. So that's our maximum height reached. Now, again, just like before, our part B was answered already, and we found that the answer for how long it takes to reach that maximum height was 3 seconds. So there you have it. Hope that helps. And I want you to notice that these numbers are kind of ridiculous, right? Like if you notice 44 meters, well, that's like 14 stories high. This ball is going really, really high. So just so you know that sometimes some of these word problems that we have aren't true to real life, but it still gives you an idea of what's happening and how the quadratic equation or the quadratic, any given quadratic works. It goes like up and then down, and the maximum is reached here. It takes this long, half the time to get there, because half of the time it goes up and the other half it goes down. And then our height is how high it goes, the highest, the maximum, the y value of the vertex. Okay, so good luck with the exercises, and the next video is going to look at another type of word problems, which is the number type.